Yeah, so I did update Canvas this morning with the quiz date, the online practice dates, senior exam date. So it's all out there for you. All right, sine function. So in order for a function to have an inverse, it has to pass the horizontal line test, and like we just talked about, sine, cosine, and tangent fail the horizontal line test like significantly. So what we have to do is there's pieces of this function that we're going to use to take the inverse. For sine, that restriction is going to be from negative pi over 2 to pi over 2. So that piece of the function is all we're going to use to do the inverse. You are going to be asked to graph the inverse on your quiz. I'm going to say that again so everybody hears me. You are going to be asked to graph the inverse on your quiz. It's kind of tricky if you don't know how to do it. So I always start with this table. Just normal old sine of x. So at negative pi over 2, what's sine? And you can think back to your unit circle. Negative pi over 2 is down here. At negative pi over 2, sine is negative 1. And that's this point from your sine graph. That maybe I should use a different color there so you can actually see it. That's this point from your sine graph that you guys took that test on. At 0, sine is 0. And again, you can think unit circle, like angle value, or you can think like the graph. Whichever works for you, pick it and stick with it. And at pi over 2, on your sine curve, sine is 1. At pi over 2 up here, if you're thinking unit circle, sine is 1. So you're restricted from negative pi over 2 to pi over 2. That's the restriction to the original function. This right here is the domain of your original. Out of space. That's going to become the range of our new function. So we're just going to switch. So this table right here, if you take these three ordered pairs and switch them, you've got the inverse of sine. And this is what you get with that button on your calculator. Remember before the test I said, oh goodness, don't use sine to the negative 1 for cosecant. You have to put in 1 over sine. That's because sine to the negative 1 on your calculator gives you this. So we're switching our x's and y's. And it kind of hurts to do it. So I'm going to look at both pages at the same time. So instead of negative pi over 2, negative 1, I'm going to have negative 1, negative pi over 2. 0, 0 is the same if you switch it, just so you know. And instead of pi over 2, 1, I'm going to have 1 pi over 2. And I've taught this for lots of years now, and I still don't graph the inverse without making this table first. I make this table, I switch the x's and y's, I plot them. Make the original table, inverse table, plot your x's. Okay? So let's do that. You are going to be given this almost exact same thing on your quiz. Okay? So at x equals negative 1, y equals negative pi over 2. Negative 1, negative pi over 2. At x equals 0, y equals 0. At x equals 1, y equals pi over 2. It's helpful that this is scaled the way it is. That's on purpose to make it easier for you. And then this is like a little... It's that little piece of your graph from right here, just reflected over the line x equals y equals x. Okay? Domain here, domain is always your x's. So our new domain is negative 1 to 1. That was the range of the original. Our range is the same as the domain of the original. The range is negative pi over 2 to pi over 2. those questions right there are really trivial if you graphed it right. Right? Because you have, I mean, you're just endpoint. No, like these don't go on forever. It's a little sliver. It's a little kind of curvy sliver. Okay? And Mrs. Krause added this nice note here. Although there are many ways that you can just restrict the domain of sine to get a one-to-one function, you could pick any sliver that passes the horizontal line test. Mathematicians have agreed to this interval. It gives you negatives and positives. It's right around 0, so your numbers, like your angles, are nice and small. Okay? So here's how we use it. Here are a couple ways that you can see this. When you're doing sine inverse, there are two ways that you can see it written. Sine to the negative first or arc sine. Those are the same. So sine to the negative first of x is equal to arc sine of x. And when you're working with these, actually, I'm going to take that x and y out and just tell you what because it's all flipped around on you. Out here is the angle, and in here is the value. And you can see that here. So you'll see more questions like 4, 5, and 6 than you will like 1, 2, and 3, because those are pretty unit circle-y. But so you're going to be thinking to yourself where instead of what is the value. When you're doing unit circle, you were thinking what is the value of sine at pi over 6. Now you're thinking where is sine radical 3 over 2. Okay? But we're going to restrict it to just, for sine, we are just looking quadrant 1 and quadrant 4. So we're just looking here. So what this guy, sine of x, or sine inverse of x equals pi over 2. What's the value of sine at pi over 2? It is 1. I'll answer. Sine inverse of x equals pi over 6. What's the value of sine at pi over 6? It's 1/2. Sine inverse of x equals negative pi over 6. What's the value of sine at negative pi over 6? Remember, negative angles are just going to wrap this way. And that's going to be negative 1/2. For sine and tangent, you're just going to do negative, negative, or positive, positive. They're going to work nice like that. Here's where it hurts a little more. Arc sine of 1. So 1 is the value. What's the angle where that happens? If sine is 1, what's the angle? Pi over 2. If sine is 1/2, what's the angle? That's the question here with arc sine of 1/2. Pi over 6. And you're not going to list the other place. That happens in quadrant 2 as well, but quadrant 2 does not exist to us if you see arc sine or if you see sine inverse. And what about arc sine of radical 3 over 2? So where is sine radical 3 over 2? Pi over 3. It also happens in quadrant 2, but quadrant 2 does not exist to us anymore because we see arc sine. Yeah. For sine, that's just 0. So because of the way sine works, it's just 0. You don't put pi, because pi doesn't, because we're just looking here for sine. Okay? All right, let's look at cosine. We can't restrict cosine the same way, because if we looked at cosine from negative pi over 2 to pi over 2, it doesn't pass the horizontal line test. We can draw a horizontal line and hit it 2 places. So this is why cosine is different. Cosine, we're going to restrict between 0 and pi. The nice thing about that restriction is that you don't have to worry about any negative angles. You're going to just use the angles as you use them normally. All positive angles. Okay? So our restriction for cosine is different. Our restriction for cosine is 0 to pi. And so we're going to do 3 little ordered pairs so we can flip them and graph them. Our 3 little ordered pairs at 0, cosine is 1. At pi over 2, cosine is 0. And at pi, cosine is negative 1. I'm going to do the same thing that I did with the last one. I'm going to dual page this so we can just take this, switch those ordered pairs, and copy them down. So the inverse, we just switch the x's and y's. 1, 0, 0 pi over 2, negative 1 pi. And I know those aren't in order from greatest to least for your x's. If that totally bothers you, I don't know, switch them around. Put them in the right order. If you need, like, if you want to do a different table where you have negative 1, 0, 1, that's fine. I think it's more important just to get all the x's and y's switched around. Good so far? Okay, let's graph it. So 1, 0, over 1, up 0. Oops, let's actually be able to draw. 0 pi over 2, so over 0 up pi over 2, and negative 1 pi, so negative 1 up pi. Again, it's just a little sliver. It doesn't go on forever. Do not draw arrows on it. Domain here again is negative 1 to 1. And range is 0 to pi. Question? Clear? The little tables are the key to getting those graphs right. I can't say that enough. Like, I don't graph them without them. Graph your 3 points for your normal guy, like normal graph, and then flip them and graph your 3 points. Okay, where's cosine 1/2? Pi over 3. Yep, pi over 3. Pi over 3. So remember, pi over 3 is like the tall one, so you're going over a little bit and up a lot. So over is your cosine value. What about cosine inverse of negative 1/2? 2 pi over 3. And again, both of those values happen other places, but the other quadrants do not exist to us when you see inverse or when you see arc cosine. So if it's helpful for you to kind of, you know, draw yourself a little picture, for cosine, that's where you're looking, quadrants 1 and 2. For inverses, only one answer exists. Only one answer. Okay, cosine is radical 2 over 2 where? Pi over 4, I heard somebody. Negative radical 2 over 2? 3 pi over 4. Radical 3 over 2? There's our pi over 6. And negative radical 3 over 2? 5 pi over 6. Tomorrow is just about practicing with these. Okay? Just about practicing with those. Good? Got them down if you want them? Okay. Tangent. Tangent has the same restriction as sine. It's nice for something to be consistent, I guess. So tangent's restriction is negative pi over 2 to pi over 2. That gives you one of those little infinite curves. So this one is going to have arrows at the end when we draw it. Here's the thing. At negative pi over 2, we have asymptotes. Because our function is undefined. If you want to write undefined there, that's fine. I'm writing what's actually happening with, because we're going to flip that and it's going to be an asymptote. At 0, tangent is 0. Mrs. Krause and Miss Stanhouse have added a couple boxes here. I think that those are for pi over 4 and negative pi over 4, because those are helpful in graphing this. At pi over 4, tangent is 1, and at negative pi over 4, tangent is negative 1. And again, our restriction is negative pi over 2 to pi over 2. And we'll write the domain and range very formally here in just a second. Okay, so here's what happens with tangent. We have that point at 0, 0. Lovely. And pi over 4, 1, we're going to switch that. Again, we're just switching our x's and y's. That's the way to make this graph happen. So it's going to be 1 pi over 4 and negative 1 negative pi over 4. So 1, negative pi over 4, 1 pi over 4. You're going to have to estimate a little bit. The nice thing that happens when you have asymptotes, if you had asymptotes that were vertical, these are vertical, they become horizontal. So now we're going to have horizontal asymptotes at negative pi over 2 and pi over 2. So I'm not even going to put those in my table. I'm just going to make a note. Horizontal asymptotes, they're going to be at y equals pi over 2 and y equals negative pi over 2. Do you have to note them? No, but you have to graph it right. So just graph it right. So make a nice little horizontal dotted line down here. Let's make it actually look dotted. And a nice horizontal dotted line up here. And approach them and don't cross them. So these were x equals asymptotes, and they became y equals asymptotes. Domain here is all reals. Our range for tangent was all reals, right? So our domain is all reals. What's the range going to be? What y values are we using? Yeah, negative pi over 2 to pi over 2, but we're not really using negative pi over 2 and pi over 2. So this guy is the only place where you're going to do parentheses. It's a hard switch to make, and it's one that I screw up sometimes. Make sure that you're using parentheses there, since you're not drawing points on negative pi over 2 and pi over 2. Okay. Tangent values, if it helps you, you can highlight or draw yourself a little picture. Sometimes it's even helpful, as you're practicing tomorrow, it might be really helpful to just write out your options. So your answer options for tangent are 0, pi over 6, pi over 4, pi over 3, pi over 2, and then the negatives. Negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. Those are your only options for tangent and for sine. It's nice to have a small number of options. Okay, let's see these real quick. What's arc tan of 0 or tan inverse of 0? 0. Where is tangent 1? Positive 1, pi over 4. Where is tangent negative 1? Negative pi over 4. Where is tangent negative radical 3 over 3? Well, 3 plus 3 is 6. And I know my only options for 6, they're positive or negative. So this one's going to be the negative. arctan of radical 3 over 3 is positive pi over 6. And arctan of radical 3 is just pi over 6. I think that's it. On the back of your notes, you have an overview of what the graphs look like.